Hi students, welcome to this video session. My name is Samuel Chukwu Emeka. In this video session we shall solve problems on exponents. This is exponents part 4. Please, it is highly recommended that you view the videos in order, that you view exponents part 1, exponents part 2, and exponents part 3, so that you understand the theory and the laws of exponents prior to the calculations on exponents. So we have several questions. We shall just solve them one at a time. It is recommended also that as if I write the first question and I solve it, then if I write the next question, the second question, you can pause the video. You can pause it, try to solve it on your own, and then play it back to check whether we get the same answer. We are going to use the knowledge we had in the previous 3 videos to solve the questions. Let's get started. Now the first question here, 3 exponent negative 2 plus 3 exponent negative 1 plus 3 exponent 0 plus 3 exponent 1 plus 3 exponent 2. So the negative exponents, we say that a base with a negative exponent is the reciprocal of the same base with a positive exponent. So this is a 1 over 3 squared plus 1 over 3 exponent 1 plus the law of exponent 3, anything to exponent 0 is 1. So this is 1 plus 3 exponent 1 is 3 plus 3 exponent 2 is 9. So this will be 1 over 9 plus 1 over 3 plus 1 over 1. We can make all these fractions, okay? Plus 3 over 1 plus 9 over 1. So what is the LCD? You know, when you're solving fractions, you can view my videos on adding and subtracting fractions. The LCD here is 9. So we have to find the equivalent fraction with 9 as the denominator. So this gives 1 over 9 plus this we have to multiply by 3. When you multiply the denominator by 3, 3 times 3 is 9. You also do the same to the numerator. So the equivalent fraction, 1 times 3 is 3 over 3 times 3, 9. Plus, this is 9 over 9, plus 1 times 9 is 9, and 3 times 9 is 27, plus 1 times 9 is 9, and 9 times 9 is 81. Now they have the same denominator. So I now go ahead and add the numerator. So this becomes 1 plus 3 plus 9 plus 27 plus 81 all over 9. And our final answer becomes 1 plus 3 is 4. 4 plus 9 is 13. 13 plus 27 is 40. And 40 plus 81 is 121. 121 over 9. And this becomes your answer. Question 2. negative 1 over 3 exponent negative 2 minus 1 over 4 exponent negative 2 plus 1 over 2 exponent negative 2. Okay, so we still apply the law of exponent. Negative exponent, a base with a negative exponent is the reciprocal of the same base with a positive exponent, with the corresponding positive exponent. So this is a 1 over negative 1 over 3 all squared minus 1 over 4 all squared, okay, plus 1 over 2 all squared. Okay. Now let's go ahead and kind of have kind of a rough work so that we can do these denominators here. Negative 1 over 3 all squared gives us negative 1 over 3 times negative 1 over 3. Negative, you do the signs first. Do the signs first. Negative times negative is positive. 1 times 1 is 1 over 3 times 3 is 9. Then 1 over 4 all squared will give you 1 over 4 times 1 over 4. 1 times 1 is 1. 4 times 4 is 16. And then 1 over 2 all squared will give you 1 over 2 times 1 over 2. 1 times 1 is 1. 2 times 2 is 4. All right. So we can now finish this up. This now becomes 1 over 9 minus 1 over 16 plus 1 over 4. Now, I am going to do this step by step. This is the same thing as saying 1 divided by 1 over 9. That is the same thing. Minus, I can put this in parentheses, 1 divided by 1 over 16 plus 1 divided by 1 over 4. Step by step. Now this becomes 1 times 9 over 1 minus 1 times 16 over 1 plus 1 times 4 over 1. So this becomes 9 minus 16 plus 4. 9 minus 16 is negative 7 plus 4. You owe 7, you have 4. You owe 3. Negative 3. And this becomes false. Question 3. We have 1 over 2 1/2 minus 1/3 plus 1/6 exponent negative 3. So we still, there are several ways we can do this. Because this is an entity in a parenthesis, we can first of all do the parenthesis, then we do exponent negative 3, we convert it to a positive exponent and then solve. Or we can go ahead and convert to positive exponent, then do the parenthesis, then solve. Whichever way is okay. But it doesn't matter whichever way. I can show you both ways. Okay. Now let's go ahead and try the first way. If we try the first way, I kind of want to write out this, and I might write here just rough work here. You know, kind of rough work. So 1 over 2 minus 1 over 3 plus 1 over 6. This is the same thing as saying LCD is 6. LCD is 6. So 2 times 3 is 6. So this is 1 times 3, 3. Minus 3 times 2 is 6. This is 2 over 6. Then plus 1 over 6. 3 minus 2. 3 minus 2 plus 1 over 6. Which is 3 minus 2 is 1. 1 plus 1 is what? 2 over 6. And that is 1 over 3. Okay? Let's check it again. 3 over 6 minus 2 over 6, which is 1 over 6, plus 1 over 6, which is 2 over 6, which is 1 over 3. So this is 1 over 3, 1/3 exponent negative 3. And that will give us what? 1 over 1/3 exponent 3. That is what it gives us. Then from here we now have 1 divided by, we can have by the side 1/3 exponent 3 means 1/3 times 1/3 times 1/3. Okay, so this gives us 1 over 27. 3 times 3, 9. 9 times 3, 27. So 1 divided by 1 over 27. So this is 1 divided by 1 over 27, which is 1 over 1 times 27 over 1, which is 27. And this becomes your answer. This is one way of doing it. Another way you can do it is you can go ahead and from here, from 1 over 2 minus 1 over 3 plus 1 over 6 exponent negative 3. If you want to change it to positive exponent first, that's okay. So this becomes 1 over 2 minus 1 over 3 plus 1 over 6 exponent 3. And this becomes 1 over, then you now do this. This is 1/3 all cubed. And that gives us 1 over 27. And of course that gives us 27. So which way you want, that's up to you. Question 4. We are getting there. I wrote out all these questions so that we can do it one at a time. 3y exponent negative 3 all over 5y all exponent negative 4. So we kind of want to do this step by step. That is what we want to do. We can write out our rough work. We can kind of draw a line here where we can show our work. Let's do it step by step. Let's start with the numerator. Because we have exponent, okay, we've got to do it step by step. So 3y exponent negative 3. So what you do here is you use the law of exponents, right? You dissociate, you solve, then you associate. This law, if you use the law of exponents, this is 3 exponent negative 3 times y exponent negative 3. Okay, you can do it this way, or you can go ahead and say 1 over 3y exponent 3. Whichever way is good. So this will be 1 over 3 cubed y cubed, which is 1 over 27 y cubed. This is the top one. 1 over 27 y cubed. Okay. Then the bottom, the numerator, the top is numerator, the bottom is denominator. We have that 5y exponent negative 4 is 1 over 5y exponent 4. And that will give us 1 over 5 exponent 4, y exponent 4, which is 1 over 5 times 5, 25 times 5, 125 times 5, 625. 625 y exponent 4. So that is the denominator. So what we have here is this. 1 over 27y cubed, all divided by 1 over 625y exponent 4. Now, let's complete that. We now have 1 over 27y cubed divided by 1 over 625y exponent 4. For division, when you convert it to multiplication, you flip the fraction on the right hand side. Second fraction. Fraction on the right hand side. So this is times 625y exponent 4 over 1. And your answer becomes 625y exponent 4 all over 27y exponent 3. Now, we can now finish this up. Remember, we still have work to do because this is y, this is y. So this is like saying 625 over 27. Dissociate. Dissociate means separate. Separate, you know, constants stay by yourself, variables stay by yourself, like variables stay by yourself. So this is y exponent 4 over y exponent 3. And that gives you 625 over 27 times y exponent 4 minus 3. That becomes, from here, that becomes 625 over 27 times y1. And then you can now associate. Associate. So this becomes 625y over 27. And this becomes your answer. So when you have mixtures, when you have constants and variables, you know, or several variables, several different variables, you want to dissociate, then solve, and then associate. Now, it all depends. You've got to, first of all, depending on your question, you might want to first of all apply the law of exponent first. Then later on you dissociate, solve, and then you associate. We will look at more examples like that. Question 5. Question 5, we have this. You have a bigger parenthesis there. D exponent negative 3 and negative 4. D negative 2 over D negative 6, all exponent negative 1. Alright, let's look at this now. You probably do not want, you know, we are trying to solve several varieties. We are going to solve several varieties, and by the end of this video you should have a good understanding of how to solve exponents, no matter what type they give you. If we look at this, okay, and there are several different ways you can do. You must not use one method. There are so many methods to solving these questions. If you look at this first, you can either make it, you know, you have the bigger exponent, that is the bigger parenthesis. You kind of have two parentheses here. But the bigger one is exponent negative 1. You can change it to, you know, 1 over the reciprocal of the positive exponent. But you probably don't want to do that. Why? You can do that, there's no problem, but we want like shortcuts. Well, not really shortcuts, but, you know, time-saving methods. Methods that will save time. You see the fact that when you multiply a negative times negative, it's going to give you a positive. So we want to use that and see how we can do this work. So first of all, let's start with the inner parenthesis. let's fix the inner parentheses first, then we see what we can do with laws of exponents before we now do the outer parentheses. Like I said, it is not the only method. It's just, you look at it and you find out what method should I use that will save time. Now this will now be, if we apply the laws of exponents here, d -3 times -4, then this is times -2 all over d exponent -6, then exponent -1. Because this means times, that's times. So this will give us d -3 times -4 is 12. So 12 times d exponent -2 all over d exponent 6. Then all exponent -1. Yeah, I prefer to do it like this first than doing it the reciprocal first. Yeah. And this is a homogeneous in d. So it's easier if you can just fix it. If it's homogeneous in d, you might want to just do it like that first. So this gives me just a single d. This is 12 plus -2, then minus 6, all exponent -1. Yeah, from law of exponents. So this becomes a single d, 12 minus 2 plus 6, exponent -1. And that becomes d, 12 minus 2 is 10 plus 6 is 16, exponent -1. So this gives me d 16 times -1, and that is d exponent -16, and that is 1 over d exponent 16. You must not do it this way. If I can do this another way, I can do this like 2 or 3 different ways. But we've got 12 problems in this video, so we kind of wanna see what we can do to not to make it too long. Question 6. We have a exponent 8, then b exponent -4, all exponent 2, all over a exponent -2, then b exponent 5. So if you look at this here, this is the case that you want to dissociate, then solve, then associate. But before you dissociate, free these guys first, okay? Now you have to use the law of exponents, because this 2 is for a and the 2 is also for b. Yeah, from law of exponents that we talked about in previous videos. So you want to free them first, then you dissociate, then you solve, then you associate. So this is a 8 times 2 times b -4 times 2 all over a exponent -2 times b exponent 5. You see, I dissociate, then solve, then associate. So this will give us a exponent 16 all over a exponent -2 times b exponent -8 all over b exponent 5. See how I dissociated it? This now gives us a 16 minus 2 times b -8 minus 5. And this will be a 16 plus 2 times b -13. And that is a exponent 18 times b -13. And that will be a exponent 18 times 1 over b 13. Because that reminds me, in this video, all we want our answers is in positive exponents only. We don't want answers in negative exponents. We only want answers in positive exponents. So this, you have finished solving this, so you associate. We want answers in positive exponents. That was why we did the reciprocal of this. We cannot leave our answer like this, no. We've got to do that. This is now A exponent 18 all over B exponent 13. This becomes your answer. And you might want to check it again, when you solve math, it is advised, it is recommended that you kind of take a second look at it to make sure that you did not make any mistake. All right, the next one is question 7. We're almost there. Question 7 says negative 16p squared q5 q exponent 5 all over 8p5q negative 3 q negative 3 all exponent negative 2. Yeah. So the negative 2 there is for everybody. It's for the numerator, everybody in the numerator, and everybody in the denominator. So free up those first. Free up, dissociate, solve, associate. Okay? Free up. Free up. Free up. Free up. By using laws of exponents. Dissociate. Dissociate. Solve. Then associate. Associate. Join. So let's kind of solve this here. Let's solve it here. Now if we free up that gives us, you can say that this is negative 16 all exponent negative 2 times p squared exponent negative 2 times q 5 exponent negative 2. Right? All over 8 exponent negative 2 times p 5 exponent negative 2 times q negative 3 exponent negative 2. This is just one method. Some folks will do this method, some will not. Some would first of all divide, then use laws of exponents. It all depends on what you want. It all depends on what you want. Okay? Some will first of all solve that, then do that. I'm going to use another method to solve this. So whichever one you like, you can use. Now, this gives us a negative 16, and you can kind of do this. This is negative 16 exponent negative 2 times p exponent negative 4 times q exponent negative 10. This is over 8 exponent negative 2, okay, times p exponent negative 10 q over exponent 6 now. This is 6. Negative 3 times negative 2 is 6. Right? Now, what you can do here, you can do this. Negative 16 exponent negative 2 is equal to 1 over negative 16 exponent 2. Right? Which is 1 over negative 16 times negative 16, which is 1 over 16 times 16 is what? 6 times 6, 36. 6 times 1, 6 plus 3, 9. 6, 1, 6, 5, 2, 256. Yeah. Some people won't do it like this, okay? This is just a method. Then if you do 8 exponent negative 2, that gives you 1 over 8 squared, which is 1 over 64. Right? Then you now do 1 over 256 divided by 1 over 64. And that would be 1 over 256 times 64 over 1. And that would be 1 over 4. Because you can do 16 into 64 is 4, 16 into 256 is 16, 4 into 4 is 1, 4 into 16 is 4, 1 over 4. I mean, that is one way you can do it. We will still use the other method. So this will be 1 over 4 times P, this is negative 4 minus 10 times Q minus 10 minus 6. So this will be 1 over 4 times P, negative 4 plus 10 times Q, negative 16. And what we have now is 1 over 4 times P, 6 times Q, negative 16, which is 1 over 4 times P, 6 times 1 over Q, 16. Yeah, this means P exponent 6 over 1. You know, that is what it means. So when you multiply, you now have P exponent 6 all over 4Q exponent 16. Exponent 16. So this is one way to do it. But you must not do it this way. Some people will prefer this second method. I'm going to show you a second method. Now, when you look at this first, you probably might, you know that negative 16 is, you can divide it by negative 8. So you might want to take care of that first, rather than coming to involve yourself with big numbers here. Especially if you are not using a calculator, you might want to do it this second method. So this is, you dissociate, right? You dissociate, you solve, then you associate. And then you now raise this here. Then you now free up. Okay, this second method is you dissociate inside the parentheses, you solve, then you associate, and then after that you free up. Free up. That's the way we want to do it now. So this is a negative 16 over 8 times, we want to dissociate, times P exponent 2 over P exponent 5 times Q exponent 5 over Q exponent negative 3. Then all exponent negative 2. So this will give us negative 16 divided by 8 is negative 2 times P 2 minus 5 times Q 5 minus 3. All exponent negative 2. If we do that from here, this is negative 2 times P, all negative 3, times Q, 5 plus 3, then all exponent negative 2. So this is negative 2 times 1 over P cubed times Q8, all exponent negative 2. Right? Yeah. Then you can kind of free up first before you associate. So this is actually free up, then associate. Free up, and associate. There is no specific method, just do it carefully, you will get the right answer. So this is a negative 2, all exponent negative 2 times 1 over P cubed, all exponent negative 2 times Q8, all exponent negative 2. So you might want to do this one at a time. Okay, this is 1 over negative 2 all squared times. Now this you know that there's something I want to show you here. This is still 1 over, then 1 over p cubed, all exponent negative 2 times 1 over cube 8. This is all exponent 2. All exponent 2. Right? So you can kind of do the denominators first. Kind of have a rough work here. Rough work. Negative 2 all squared is 4 because it's negative 2 times negative 2. And then 1 over p cubed all squared means 1 over p cubed times 1 over p cubed. And that is 1 over p 6 because 3 plus 3. Okay, 6. Then cube 8 all squared is cube 8 times 2, which is cube 16. Now you can now associate. You can now associate. That gives us 1 over 4 times 1 over p 6 times 1 over q 16. So this is 1 over 4 times 1 divided by 1 over p exponent 6 is p exponent 6 over 1 times 1 over q exponent 16. And then you associate p exponent 6 over 4q exponent 16. And this becomes your answer. So any way you want, okay, any way you want. Just do it gradually and follow the laws of exponent. You will get it right. Question 8. We have a 3 CD squared all over 5p exponent negative 1 q exponent negative 2, then all exponent negative 1. Well, if you look at this one, you see that the second method will not really apply because with the method we just used now will not apply. We've got to, in this case, we'll still have to free up. Then we free up, we dissociate, we solve, then we associate. That is what we will do in this method. Because 3 is not divisible by 5, and then CD is the numerator, and PQ is the denominator. They are not like variables. So you want to, what you want to do here is to free up. You want to free up by using the laws of exponent. You want to free up. Then you want to dissociate. You want to free up and dissociate. Then you want to solve. Then you want to associate. These are just the terms I'm using anyway. You can call it whatever terms you want. Alright, so this is a 3 exponent negative 1 times c exponent negative 1 times, and because this is, it does not matter whether I put parentheses or not, it does not. Then times d, this is squared times negative 1. I can just write it like this, d2 times negative 1 all over. As I'm freeing up, I'm also dissociating as well. 5 exponent negative 1 times p negative 1 times negative 1, then times q negative 2 times negative 1. So this is a 3 exponent negative 1 times c exponent negative 1 times d exponent negative 2 times, because these are not the same, I can call this 1 over 5 exponent negative 1 times 1 over p exponent 1, because this is like saying 1 over that, times 1 over q squared. So this will give me 1 over 3 times 1 over c times 1 over d squared times, remember, this is 1 divided by 1 over 5, you know, 1 divided by 1 over 5, that is what it is. I can show it to you here. 1 over 5 negative 1 means 1 divided by 5 exponent negative 1, which is 1 divided by 1 over 5 exponent 1, which is 1 times 5 over 1, which is 5. So this is times 5, and times 1 over p times 1 over q squared. And then you can associate this, if you associate, you have 5 is the only guy on the numerator, all over 3cd squared pq squared. And this becomes yours. Yeah, this means like 5 over 1. If you want to put it as fraction. Question 9. C squared d exponent negative 2 minus c exponent negative 1 d exponent negative 3. Alright, this is pretty straightforward. We want all positive exponents. That is all we want. Now this is c squared times 1 over d squared minus 1 over c times, because this is 1 over c exponent 1. So times 1 over d cubed. So this is a c squared over d squared minus 1 over cd cubed. 1 over cd cubed. What's the LCD? LCD will be what? CD cubed. So if we have over CD cubed minus over CD cubed, what will you do to this squared to give you CD cubed? You multiply by CD. Okay, so C squared times CD. That is what we have now. C squared times CD. Okay, which is C cubed D. Right? Because we want the LCD is CD cubed, but what you will multiply the denominator d squared by CD, it gives you a CD cubed. So you do the same thing to the numerator, c squared times CD, right? Gives us c cubed d. So this is c cubed d. That's the equivalent fraction of that. Then this is of course 1. And then you can now subtract them because they have the same denominator now. So this will be c cubed d minus 1 all over cd cubed. And this becomes your answer. Question 10. (7p) exponent negative 2q plus 10p exponent negative 1q exponent negative 2. So you see we are doing varieties of this. So this is 7 times 1 over p squared times q plus 10 times 1 over p times 1 over q squared. So this will be 7q over p squared plus 10 over pq squared. What's the LCD? LCD will be what? P squared q squared. If you don't know how I found LCD, please, it is important that you review my videos on factors and multiples. It is very important. LCD has everybody. It contains everybody. But I can show you a quick way. If you have p squared, you have p times p. If you have pq squared, you have p times q times q. So LCD, LCM actually, this is LCM, this common multiple. Because this is denominator, we say LCD. So if it appears twice, call it one time. So this is P times Q times Q. And that is P squared Q squared. If it appears two times, call it one time. Please view my video on those. So now, let's finish up this. So from here, this is over, let's find the equivalent fraction. Over P squared Q squared plus over P squared Q squared. What will you multiply by P squared to give you P squared Q squared? It's Q squared. Multiply it also to the numerator. That will give you 7Q cubed. This is like saying 7Q times Q squared, which is 7Q cubed. Here, what will you multiply by PQ squared to give you P squared Q squared? P. So you do 10 times P also, 10P. 10P. So this, your answer becomes 7Q cubed plus 10P all over P squared Q squared. This becomes yours. Two more to go. 11. Now let's look at 11, 27 over 9, then 27D, 1 cube. We now have fractional exponents. We shall do more of this in our other videos. This is what we have as as number 11. So you have fractional exponents. Please don't be scared of fractions. Do not. We're gonna do it. Okay, we'll do it. And you might wanna walk inside first. You might wanna dissociate inside, solve, then free up. Or you might wanna multiply, you know. If you don't wanna deal with big numbers, you probably, because 27 is divisible by 9, and this is D and this is D, you probably might wanna do the other method we did. That second method we used. So if we use that method, this will be 27 divided by 9 times D 1 cube, then minus 1 over 4. I mean D 1 over 3, D exponent 1/3 minus 1/4, all exponents squared. So this will give you 3 times. Now let's look at the D. 1/3 minus 1/4 is what? Let's have some rough work here. 1 over 3 minus 1 over 4. LCD is 12. So this is you multiply by 4, so this is 4. Here you multiply by 3, this is 3. And this will be 1 over 12. So this is 1 over 12. Exponent 2. So this gives you what? 3 squared times D 1 over 12 times 2. That is what it gives you. Right? So can we complete this now? If we complete it from here, this will be 3 squared is 9 times D 1 over 6, because 2 divided 2 is 1, 2 divided 12 is 6. And you now associate 9D exponent 1 over 6. This is the positive exponent. Now what if they asked you to leave it as a radical? A radical. What will you do? If they ask you to leave it as radical, it will be 9/6 of D. 9/6 of D. If they ask you to leave it as radical. Last but not the least, question 12. 64 m 1/3 all over 16 m 5 over 9, then all exponent 3. So this will be what? You can do that, 64 over 16 times m. You can do 1/3, 1 over 3 minus 5 over 9. Then all exponent 3. 64 divided by 16 is what? 4 times m. Now let's look at the 1 over 3 minus 5 over 9. LCD is 9, so we have over 9 minus over 9. 3 times 3 will give you 9, so 1 times 3 is 3, and this is 5, so this is negative 2 over 9. 3 minus 5 is negative 2. Negative 2 over 9, so m exponent negative 2 over 9, then all cube. So from here, this will give us 4 cube times m exponent negative 2 over 9 times 3. So this is a 64 times m. 3 into 3 is 1, 3 into 9 is what? 3. So this is negative 2 over 3. So this is a 64 times 1 over m, 2 over 3. And this will be 64 over m, 2 over 3. And this becomes your answer. In positive exponent, if they ask you to leave it in radical, then it will be 64 over cube root of m. Please, we are going to stop here tonight. Watch out for the next video, and it's going to be more challenging problems. Thank you so much for listening. Feel free to ask your questions. I'll be